In this video, you're going to learn about how to simplify radicals. In the past, at the beginning of the year when we did in Unit 1, we evaluated radicals, where you actually typed in the square root of a number and got its decimal counterpart, or the cube root of a number and got its decimal counterpart. But now we're going to take and break them down. So in order to break them down, you have to know the parts of a radical. Okay, so it looks like this, and I'm going to put a generic letter underneath it to represent any number or combination of variables and numbers that may be underneath the square root sign. In the past, we've always called it the square root sign because that's what we know it as, but it officially has a name and it's called the radical sign. So anytime you hear that word mentioned, it's talking about the square root symbol. And the number underneath, or the variables underneath, whatever the case may be, okay, those also have a name, and those are called the radicand. So if you use me using those words interchangeably, that's what they stand for and that's what they mean. So get used to recognizing them and hearing them as well. Right? In order to be in simplest form, there are some rules that have to apply. Right? So radicals are in simplest form if these three things are not there. Right, so the first thing you want to make sure you have is that no perfect squares other than a 1, because 1 is a perfect everything and goes into everything, are in the radicand. So that piece underneath the square root sign can have no more perfect squares in it other than a 1. The second thing that has to be true is that there can be no fractions left in the radicand. You will start with them in your problem, but by the time you get done simplifying, there will be no more fractions left over. And the third thing that you have is that no radicals can appear in the denominator. Again, they can start that way in the original problem, but when you think you're done with your problem and they're still down there in the denominator, then that means you're not finished. So as long as these three things do not exist in your final answer, then you've simplified it the best you can. Hopefully it's the correct way. All right, in order to simplify square roots, though, you have to know your list of perfect squares. So we have you memorize the first 20. Or sorry, say the first 15. If you know more than the first 15, then obviously that'll be a stronger suit for you, but the first 15 is a requirement. All right, so 1 is a perfect everything. 2 squared would be 4, 3 squared would be 9, then 16, then 25, then 36, then 49, then 64, then 81, then 100, then 121, 144, 169, 196, and 225. And the list does keep going, but usually this is what you need are the first 15 because everything can be broken down using one of these 15 numbers. If you need more, you can always explore for more. All right, so in order to simplify, here are some examples, and we're going to put all the different varieties in this section. Okay, so you will have several examples of all the different types that you're going to be facing. Okay, and again, in this part, there are no decimals allowed. You are not evaluating, you are simplifying these problems. All right, so what this looks like for a single number is if I have the square root of 48, okay, I want to find the largest perfect square from my list that divides into 48. Now, there are several numbers in that perfect square list that divide into 48. For example, 4 goes into 48, but 4 is not the largest number. If you used 4, you would have a problem that is not finished and you would have to break it down more. So in order to prevent having to do extra work, pick the largest one and then break it down. So if you start towards the 49 and work your way to the left and look at those numbers, you'll find very quickly that 48 can be broken down into the square root of 16 and the square root of 3, because 16 times 3 is 48. Because it's the square root of 48, both of your numbers have to have the radical sign around them, and your first number needs to be your perfect square. Because what happens when you go to simplify this to get your answer, the square root of 16 is a perfect square. It's the number 4. Notice the square root sign is gone. The square root of 3 is a non-perfect square, so it stays in the radical sign. This is your answer. So if you get in the habit of putting your perfect square first and your non-perfect square second, it'll actually make it easier for you to get to the answer. All right, so the next one that we want to take a look at is going to be the square root of 50. Again, you want to go to your list of perfect squares and find the largest number that goes in. Okay, and 25 is going to be it. So we want to put the square root of 25 and the square root of 2, because 25 times 2 is 50. Okay, and then the square root of 25 is 5, so the radical sign is gone. And the square root of 2 stays square root of 2. So 5 radical 2 is going to be your final answer there. All right, so let's get a little bit larger of a number here. Let's do the square root of 240. Okay. And again, you want to find the largest number that goes in. 4 goes in, and then I'm sure there's a bunch of other ones that go in as well. Okay, but when you get down to it, you're going to find that 16 is the largest perfect square that goes in, and 16 times 15 is what makes 240. Okay, so your perfect square goes first and your non-perfect square second. Square root of 16 is 4, and then radical 15 goes last. Square root of 15, there's no other perfect square in 15 other than a 1. All right, so it's not about what numbers can divide into it, it's what perfect squares can divide into it. So you really have to stop and change your thinking a little bit. All right, so that's some of the single numbers that we're doing. Okay, but then you're going to see that there's going to be some problems that have not just a single number in the inside, but they have numbers on the outside as well. All right, so that's what we want to take on next. If you have 3 radical 20 and you are asked to simplify this, the 3 on the outside is just a number being multiplied times your square root of 20. The radical 20 is what needs to be broken down. Leave the 3 alone until we get to the end. Square root of 20 has the perfect square of 4 in it, and 4 times 5, so that's square root of 4 times square root of 5. All right, so now when you go to get this part done, square root of 4 is 2, and then radical 5 is square root of 5, but you still have to bring down that 3, and it's being multiplied to everything in there. Okay, and on your outside numbers, you multiply your outside numbers together, you put them together. So 3 times 2 is going to make 6, square root of 5. And that's going to be your final answer. Okay, so your final numbers on the outside do want to be put together to make your one number on the outside of it. All right, so then if we go to number 5, and we have negative 1/2 times the square root of 108. Again, we'll deal with the negative 1/2 in a minute, but you want to break down your 108. 108 can be divided by a couple different perfect squares, but the largest one you should find would be the square root of 36, and then 36 times 3, so square root of 3. So now when I do the square root of 36, that's 6, and then radical 3 stays radical 3. Bring down your negative 1/2, and that's going to multiply times the 6. All right, so now we want to put those outside numbers together. Negative 1/2 times 6 is going to produce negative 3, and then radical 3 stays under the radical sign. So there's your final answer on that one. So again, numbers on the outside, you just multiply them to your simplified number on the outside so that you can combine them together. All right, so now you're going to see some that have 2 radicals in the original problem. All right, so if I have the square root of 2 times the square root of 14, if you're looking at both of those, neither one of them have a perfect square in them from the list. So you may think, well, I can't do anything to this problem. But if you stop and think about it, 2 square roots can multiply together. If you put them back together, you have the square root of 28. Square root of 28 has a perfect square in it. So now take and break it down using your list. And 28 can be divided by square root of 4 and square root of 7. And the square root of 4 is 2. Square root of 7 stays under the radical sign. So the original problem didn't start off in a good way, but you can put the 2 numbers back together, okay, and then you can break it down the way you know it's supposed to. So for a side note over here next to this problem, if there are no perfect squares, then multiply back together and split it apart correctly. Now, if one of them was a perfect square, you would continue on as normal. But when they're both not perfect squares, then you want to try a new strategy to get to an answer. All right, so the next example that we're going to take a look at is still going to involve some of that negative square root of 6 times the square root of 3. Again, neither one of these are a perfect square, so what I want to do is put them back together. The negative sign stays outside the radical. You don't mess with that. But 6 times 3 is going to produce the square root of 18. 18 does have a perfect square in it, so when I break it down, that's square root of 9 and square root of 2. The square root of 9 is a 3. Bring that negative sign down because that negative sign was on the outside. That makes it negative 3. And then square root of 2 stays in your radical. So here's the final answer to that one. Again, put the two numbers together and then resplit it apart. That's multiplication. Now if we look at division, you have the square root of 7 over 16. If everything is under the fraction or under the radical sign, if the whole fraction is underneath it, then that means it splits apart to be the square root of 7 over the square root of 16. Both of them have the radical sign. So if you split it apart, you can actually see the numbers that can break down and the numbers that can't. There's nothing to do to the square root of 7. It is what it is. There's nothing you can do to break it down. But the square root of 16 is a perfect square, so that turns into a 4. This is your final answer. Remember that the simplifying rule said there can be no radical sign in the denominator, so we got rid of that. It can be in the numerator. All right, so looking at the next one, still using a division problem. If I have square root of 18 over 3. Now some of you may want to and be tempted to say 18 divided by 3 is 6, but you can't do that because the 18 is under the radical sign, the 3 is not. All right, so if they're both not under it, then you have to break down whatever you've got. 18 breaks down into square root of 9 and square root of 2. Okay, so for the top, I'm going to have 3 square root of 2, and the bottom is still going to be the 3. Just like in the multiplying problems, we multiplied outside numbers together. Same thing happens with division. If you can reduce or divide your outside numbers in a division problem, you do have to do that. 3 divided by 3 is 1. So your final answer is just square root of 2, or you can put a 1 in front of it. But remember, 1s in algebra are invisible, so without it, your answer is still the same. Okay, so square root of 2 would be just fine. Okay, so now let's keep looking at a few more. If you have under your square root sign a fraction and you don't see any perfect squares, remember with multiplication we said put the two numbers back together and then resplit it apart. Okay, so for division, if there's no perfect squares, reduce the fraction first, because usually when you do, you'll see a perfect square come out. So if I divide 80 and 45 by 5, my new fraction is going to be the square root of 16 over 9. Okay, just by reducing it, I ended up with 2 perfect squares. So this is the square root of 16 over the square root of 9. Square root of 16 is 4. Square root of 9 is 3. So my final answer is 4/3, and there's no more radicals anywhere in the problem. Okay, so that's what the beauty and the easiness of simplifying first will actually do for you. Okay, so let's take a look at another one. And this one has a number outside of the radical with a fraction inside. Okay, the number outside, you want to make it look like a fraction, so the 8 is technically over 1, so it's in the numerator. So when you go to break your fraction down, you're going to have 8 on the numerator and square root of 3 in the numerator, and then on the bottom, the 1 is there that you don't need to write, and the square root of 4 is on the bottom. If you want to do this to make yourself feel better about it, then that works too. All right, so now when I actually go to look at this, 8 divided by 1, my outside numbers, is still going to stay 8. Square root of 3 cannot break down, so it stays radical 3. Square root of 4 turns into 2. Again, look at your outside numbers, and this time 8 can divide by 2. So my final answer is going to be 4 radical 3. Okay, and that's where you'll stop when you can't break it down any further. All right, last one under this category. And we will practice a lot with this in class as well. Right? This is just getting you used to seeing it and hearing how to mess around with it in order to come out with the result that you want to happen. All right, so in this one, everything is under the radical sign, but you'll notice that the very first number is a perfect square, so you do not want to put them back together. That would be a long way through this problem that you still could end up at the same answer, but it would not be advisable. At this point, you would want to take and do the square root of 81, which is 9, Okay, and then the square root of 10 and the square root of 5, because they're both under the square root sign, you can divide them. Remember when the two numbers were under the radical sign in multiplication, we could put them together? So same thing happens in division. As long as both numbers are under the radical sign, you can multiply and divide them. So the square root of 10 divided by the square root of 5 is the square root of 2. And there's my answer. So what looked like a problem that was going to be pretty difficult, right, is not as bad as it seems. Okay. All right, so then the next topic that we have to deal with, other than simplifying perfect squares, are simplifying perfect cubes. And it's going to be done very similar to what we were just doing, except now you have a different list of numbers. So this time, instead of using the list of perfect squares, we have to use the list of perfect cubes. Right? So that would be 1, because remember 1 is a perfect everything. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. Then there's 125, 216, 343, 512, etc. You don't have to go up past 6 or 7 spaces just because you can use the calculator to get what you need from there on. They usually don't have numbers that divide into any of these below 216. Right, so if we want to take a look at it, the first thing we want to note is that when you simplify these, it is done the same way as square roots, but you use your list of perfect cubes. That's the only difference. All right, so we want to take a look at what some of these examples look like. And because we've already done the big bulk of the lesson through the square roots, there won't be as many of these, but I want to show you the difference between them. If you have the cube root of 56, so notice there's a little 3 outside. That means now you're using your perfect cubes, right? So we're using our list of 1, 8, 27, etc. And 56 can divide by 8. So when you break it down, it's not the square root of 8, it's the cube root of 8. And 8 times 7 makes 56, so it's cube root of 7. So cube root of 8 times the cube root of 7, right? And the cube root of 8 is the whole number 2. And the cube root of 7 stays under the sign, okay, because it's not a perfect cube. So here's your final answer. So you're still going to have a number on the outside of your radical, and then you're going to have the cube root number inside. All right, so then for number 2, you have the cube root of 1,728. Now, if you get a number that's large, your first instinct should be to go ahead and go to the calculator and see if you can take the cube root of it. If it gives you a decimal, you know you have to break it down like we were doing. But in this case, if you type in the cube root of 1,728, it's going to tell you 12 because it's already a perfect cube. So sometimes your cube roots are perfect cubes already. Check with the calculator first before you go to try any crazy math. Okay, you will still get the same answer even if you tried to break it down into perfect cubes, but it's a lot faster to just check with the calculator first. All right, so for number 3's example, I want to do the cube root of negative 162. In cube roots, you can have negatives underneath the sign. In square roots, you cannot, okay, because an odd number of negatives produces a negative. So what you would do with that negative sign is when you go to break it down, you'll include it in your perfect cube. Okay, so negative 162 can actually be divided by 27. So we want to do the cube root of negative 27. This is where we take the negative with us. And then negative 27 times 6. So it's the cube root of 6. You don't ever want to leave the negative sign with your non-cube root number. Always put it with your perfect cube. Because when you do the cube root of negative 27, that's going to make negative 3 cube root of 6. So it comes out and is in the front of your expression. All right, so if we look at another one, just like in square roots, if there's anything outside the radical sign, you're going to use it last, and you can either do multiplication or division with it. So if we're going to break down the cube root of 750, then that breaks into the cube root of 125 and the cube root of 6. Okay, and the cube root of 125 is 5. Cube root of 6 stays cube root of 6, and then bring down the negative 2 to multiply together. These two numbers on the outside multiply together, and your final answer will be negative 10 cube root of 6. And that's where you stop. Okay, so it's just like the square roots, just using a whole different set of numbers. And then the final example that I'm going to share with you is going to be one where you have negative cube root of 28 times cube root of 4. And again, if neither one of them are perfect cubes, you want to put them back together and then break it apart, just like we did with square roots. So this would make negative cube root of 112. Notice the negative sign is on the outside this time, not on the inside. And then if you break 112 down, it can break into negative cube root of 8 and cube root of 14. Negative cube root of 8 is going to be negative 2, and then cube root of 14 stays cube root of 14. Okay. So we will continue to practice with breaking down these radicals and cube roots, and we will show you some other things that involve the same topic and the same skill. So use your notes to help you and see what you have questions about when you come to class.